Welcome to our lesson on arithmetic series. Introduction. We got a picture here. There are 10 rows of black and white blocks. So starting from the top, the first row has one block. It's one white block right there. Second row down has two blocks, a white and a black. And the third row has three blocks, and so on. We've got a sequence here. So the sequence for the number of blocks in each row would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thus we know that T1, or the first term, would be 1, and T10 has 10 blocks at the bottom. Now, suppose we wanted to find the total number of blocks in all 10 rows. We would have to add all the terms in the sequence. This is called an arithmetic series. So we would go 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. That'd give us 55. Now you might be thinking, is there a shortcut? Especially if we have a whole bunch of numbers. I mean, here it's not too bad, but if we had a whole bunch of numbers, is there a shortcut for this? Well, what if we added the first term and the last term, 1 and 10, and then we multiplied this result by half the number of terms? Let's try it out. So we've got 10 terms, so half the number of terms would be 5. And with the first term of 1 and the last term of 10, we add those two together, we get 11. And then multiply that by 5, half the number of terms, we get 55. It's the same number. 55, 55. Now, will this work every time we know the first and the last term? Well, let's look at another example and see. So here we have 4 terms in the sequence: 10, 20, 30, 40. Now, if we took those 4 terms and added them together, so we're using plus signs, which indicates a series, as opposed to a sequence that has commas between the numbers. So 10 plus 20 plus 30 plus 40, that's 100. So half the number of terms, so we got 4 terms, half the number would be 2. Adding the first and the last terms together, 10 plus 40 is 50. And we multiply 50 by half the number of terms, or 2. Look at that. We get 100. All right, so it seems to work. So we've got 2 formulas. So this is the first one. So an arithmetic sum formula when the first and the last terms are known. So the sum, remember, the sum of an arithmetic sequence is called an arithmetic series. It's the terminology we use, a series for sum. So here's our formula. S for sum of so many terms, will be the number of terms divided by 2, multiplied by the first term added to, t to the n is the term at the end, or a missing term we're trying to find, but oftentimes we do think of it as the last term. So in this case, we call it the nth term, or in terms of our formula, we're talking about the last term here for using this formula. Add the first, the last together, multiply by half the number of terms, and we get the sum of that many terms. So Sn, sum of n terms. N is the number of terms. T1 is the first term, and Tn is the nth term. So let's take an example. 3, 7, 11, 15, 19, 23. So we have an arithmetic sequence, and we're asked for the sum. So it indicates a series. So we want to take these 6 terms and add them together. Well, this particular formula tells us if we take half the number of terms, so 6 divided by 2 is 3, half the number of terms, and multiply that by the sum of the first term, 3, and the last term, 23. So 3 times 26 is 78. So we say the sum of these 6 terms would be 78. Next example, determine the sum of the sequence 17, 12, 7, comma, dot, 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 comma. The last term is negative 38. So we know the first term, 17, and the last term, but we do not know the number of terms. So what we would do here is to use the general term for an arithmetic sequence. That was shown in a previous lesson for arithmetic sequences. Now that will allow us to determine the number of terms. T to the n is equal to the first term plus n minus 1 times d. And d is the common difference. So up here, our common difference is found by taking any term and subtracting the previous term. So 12 minus 17 or 7 minus 12, doesn't matter. In either case, we're going to get a common difference down here of negative 5. So we're adding negative 5 in each case to get the next term in the sequence. So now we've got the common difference. We know the nth term. We know the first term. And we don't know n. We don't know the number of terms. So we're going to use this formula now, this equation, to solve for n. Because in order to get the sum, we need the number of terms. So determine the sum of the sequence. T to the n is equal to t1 plus n minus 1 times d. Substitute what we know. So we've got the nth term as negative 38. This term right here, negative 38. First term, 17. Added to n minus 1 times the common difference of negative 5. And use our algebraic skills, multiply to get rid of the brackets here. So we get negative 5n plus 5. Then combine 5 and 17 as like terms to get 22. Isolate the term with the variable, so subtract 22 from both sides. And finally, divide both sides by the number in front of the letter, in this case, negative 5. So we find out that n is 12. So we have 12 terms here. So since we know the first and the last terms, we will add these terms and multiply by half the number of terms. That's what that formula tells us to do. So let's do it. Sum of 12 terms, 12 divided by 2, half the number of terms. Add the first and the last term together. And we get a sum of negative 126. So we can get a sum that's positive or negative. Example 3. So you may be asking right now, well, what if you don't know the first and the last terms? Well, we're going to introduce an alternative formula here, something that will help us. So for example, find the sum of the first 10 terms of the arithmetic sequence, 2, 12, 22, dot, dot, dot. So here's our alternative formula. So let's take a closer look at it. Let's find the common difference first, because we need it in the formula. Remember, it's any term subtract the previous term, so 12 minus 2, or 22 minus 12. In either case, we get 10 as our common difference. As you can see, we're adding 10 to each of these numbers. So we've got 10 terms, so sum of 10 terms, n is 10, 10 divided by 2. And we double the first term, whatever the first term is, we have to double it. Formula tells us that. And then n minus 1, 10 minus 1 in this case, multiplied by the common difference of 10. And with that information, we can get our sum. So sum of 10 terms is 10 over 2. Then in brackets, we got 2 times 2 plus 9 times 10. 10 divided by 2 is 5. 2 times 2 is 4. And this will be 9 times 10, which will be 90. So 90 plus 4, 94 times 5. So the sum of the first 10 terms of this sequence is 470. 470. Example 4. Sum of the first two terms of an arithmetic series is 19, and the sum of the first four terms of the same series is 50. So what are the first four terms? And then we're asked for the sum of the first 20. So how are we going to do this? Let's look at the first part first. What are the first four terms? We do not know the first term or the common difference. Therefore, we have to do something a little different strategy here. It's possible to generate two equations in two variables, and then we can solve them using the elimination method. We've seen this before. Solving two equations in two variables. So let's look at the first part. So sum of two terms, S2. So it's 2 divided by 2, because that's the number of terms on the top. It's 2 times the first term, which we don't know. And then n minus 1 times d, which we don't know. So 2 minus 1 is 1, and 1 times d is just d. So here's our first equation. We have an equation where we don't know the first term or d. The second part of the question tells us the sum of the first four terms is 50. So let's substitute 4. Sum of four terms will now be 4 over 2. It's still 2 times whatever the first term is, which we don't know. And n is 4, so 4 minus 1 will be 3. 3d. This number out here is 2. So when you take 2 times, and when we multiply inside the brackets, 2 times 2 here, that's how we get this 4t1. And then 4 divided by 2 again is 2. And multiply the 2 times the 3 here, 4 minus 1. That's how we're going to get the 6. So now we've got two equations in two variables, and we can solve using elimination. So we need the same coefficient in front of one of the letters. So we've got a couple options here. I've chosen to get the same number in front of the d. So the second equation, 50 equals 4t1 plus 6d. It's got a 6 coefficient in front of the d. So in order to get the same number in front of the d here, I will multiply each of these three terms by 6. Remember in math, you can multiply an equation by the same number, and it's still the same equation, in essence, the same equation. So let's multiply this first top term by 6. And if we do, we should get 114 is equal to 12t1 plus 6d. Keep the second equation the same. So now we've got the two equations, two variables. We'd like to eliminate the letter that has the same coefficient, 6. And since the signs are the same, they're both positive. In order to eliminate, we have to subtract. So we're going to subtract all of the like terms. So 114 minus 50 goes here. 12t1 minus 4t1 goes here. 6d minus 6d is 0. It cancels out, so we're not even going to write it. So now we have an equation with one variable that we can now solve. We'll take that equation, divide both sides by the number in front of the letter. In other words, 8. So we got our t1 is equal to 8. But we don't know d yet. So we're going to substitute t1 equals 8 into either equation to find d of the common difference. I've chosen this equation. 19 is equal to 2t1 plus d. So we'll take the t1 equals 8, put it into that spot. 2 times 8 is 16. So we're looking at 19 is equal to 16 plus what? The what is our d or common difference. So subtract 16 from both sides, and we see the common difference is 3. Now, after doing all that work, we can get to answering the question. what are the first four terms of the series? Glad you asked. We know the first term is 8. The common difference is 3, so we can just go 8 plus 3 is 11, plus 3 is 14, plus 3 is 17. That's the first part. Second part was, what is the sum of the first 20 terms? Well, since we do not know the last term, we're going to use this formula. So we want the sum of 20 terms. So that would tell us that we need 20 divided by 2, in brackets, 2 times the first term, which is 8, plus n minus 1, or 20 minus 1, times the common difference of 3. So now all we have to do is just remember order of operations to get our final answer here. So inside the brackets, we have 16 plus 57, and 20 divided by 2 is 10. Sum these two numbers and then multiply by 10. The sum of the first 20 terms of this series is 730. Last example, 5. You're given the first term. We're given the sum of so many terms, in this case, sum of 10 terms. And we're asked to find the common difference. And we know the number of terms is 10. And the sum of these 10 terms is given 115. And we got the first term is -2. Now we do not know the last term. So which formula do you think is needed to determine the common difference here? What do you think? Well, let's use this formula. Sum of 10 is n over 2 times 2 times t1 plus n minus 1 times d. So sum of 10 terms will be 10 divided by 2. 2 times the first term, we're given the first term -2, plus 9d. D we're trying to solve for. So order of operations, once again, we get -4 inside the brackets first term, plus 9d. That's all multiplied by 10 over 2, which is 5. So multiply to get rid of the brackets. We get 115 is equal to -20 plus 45d. Then we would add, excuse me, add 20 to both sides. So 135 is equal to 45d. And then divide by 45 to get d. And a final statement is always good on these kinds of questions. What is a common difference? Common difference is 3. So just a brief summary. Given the sequence, T1, T2, T3, all the way down to Tn, it has an associated series, which we then indicate with addition signs. So the S for series, or sum of n terms, would be T1 plus T2 plus T3 plus, all the way down to the last term, Tn. Now, if the first and the last terms are known, we could use this formula. Sum of n terms is n divided by 2, half the number of terms, times the sum of the first and last terms. Otherwise, let's use this other formula. So it's an alternative formula where we would use the number of terms n. We need the first term. We've got the number of terms n, and we need the common difference. So that concludes our lesson on arithmetic series. Until next time, have yourself a wonderful day.